Welcome to today's lesson on 8.9a. So our lesson target is I can identify and verify values of x and y that are solution to two linear equations from intersections of graphed equations. So this is a lot, but basically we are identifying, so we are figuring out the numbers that represent x and y that are a solution, that are the answer to two linear equations. And we are looking at their graphs and specifically at the intersection, so where the two lines meet. And verify, just to confirm that everyone knows what it means, verify means to check and even to confirm. The essential question is, what does the solution of a system of linear equations tell us? So we can't yet answer that question because we haven't yet learned about the system. Okay, so a system of equations, we've already been learning about proportional and non-proportional relationships, right? So a system of equations is two or more equations that are solved together to find a solution. So on the right, we have this graph with the distance and the red and the blue line. So this is an example of a system of equations with just two equations. And the solution is a number or numbers that make all the equations true. So the solution can be represented by this intersection right here, which intersection means a point where two or more lines meet or pass each other. And then of course, because this is on a graph, we have to figure out the ordered pair or the x and the y. So the ordered pair is a pair of points in a fixed order that includes the x-coordinate and the y-coordinate. And lastly, slope-intercept form. So if we look at both of these equations, we see that they're both non-proportional relationships. So we know that if we were to write an equation, they would both be in the form of y equals mx plus b because they do not go through the origin. They both have y-intercepts, right? There's one y-intercept and here's another. And so remember that the slope-intercept form is the equation of a straight line where m is the slope. So this represents the slope. This is the rise over run, or change of y over change in x. And then our b is our y-intercept, so where the line intersects the y-axis. Okay, so we're going to start with our activity. So this activity reads, this past summer you were hired to work at a custom t-shirt shop, US Shirts. One of your responsibilities is to calculate the total cost of customers' orders. The shop charges $8 per shirt plus a one-time charge of $15 to set up a t-shirt design. So the first question we have to answer is the relationship between the number of shirts ordered and the total cost of an order proportional or non-proportional? So because we have not just $8 per shirt, but we also have another charge, I know that this is going to be non-proportional. Then question number 2 is asking for us to write an algebraic equation. So basically we're just writing an equation for the situation, for the problem. Okay, so we have y is equal to 8x because remember per means that you're multiplying or sometimes dividing. In this case, we're multiplying the number of shirts. So 8x, and then it says plus a one-time charge of $15. So we have y is equal to 8x plus 15. Then 3 and 4 are related because we have to find the total cost of the order for 3 shirts, 10 shirts, and 100 shirts. And remember that the number of shirts is going to be our x value, right? So as you can see in the table, it says complete the table of values for US shirts, round to the nearest penny. All of these numbers, the 3, 10, and 100, are our x values. So there's 2 ways to solve this, right? So we can make a table on Desmos by just typing in the equation, or we can do this by hand. And so I'm not going to do it completely by hand, but I just want to remind us that we can just plug in the 3, the 10, the 100 as our x, right? So we could do 8 times 3 plus 15, 8 times 10 plus 15, and lastly 8 times 100 plus 15. But I'm going to remind us how we can find this answer on Desmos. Okay, so we're going to type in the equation, which is y is equal to 8x plus 15. So from here, I'm going to make my table. Anytime I want to create a table for this equation specifically, I'm not going to go to plus. I'm going to go to settings and click on the table right here. And you can see that it already has some x values given, but we don't need any of those x values. So I'm actually going to change them to be 3, 10, and then 100. Okay, so we're going to use these numbers. So I see that when 3 shirts are sold, it's gonna cost $39. So I'm gonna write it in both places. And then when 10 shirts are sold, it costs $95. So 95. And then when 100 shirts are sold, it costs $815. So I'm gonna write 815 here. And as you can see in the table, we have 4 additional lines. So we gotta come up with 4 additional X values or numbers to represent t-shirts. So I'll just continue by saying 150, 200, 250, 300. And you can see all of the values that we need, right? So for 150, it was 1,200 and 15. For 200, it was 1,615. For 250 is 2015. And lastly, for 300, it was 2,415. So we are going to continue doing this, but for a different company or for a different situation. So now it's talking about, previously you explored a job at US Shirts. One of US Shirts' competitors, Hot Shirts, advertises that it makes custom t-shirts for $5.50 each with a one-time setup fee of $49.95. Your boss brings you the advertisement from Hot Shirts and asks you to figure out how much the competition might affect business. So again, we're starting by writing an algebraic equation for this situation. So we have y is equal to 550. X, remember, each means that you're multiplying or dividing. In this case, we're multiplying. And then plus the 49.95. So we're going to go ahead and make a table for this situation using 3, 10, 50, and 100 as some of our first X values so that we can answer 2 and 3 all together. So of course, now I have to change my equation. I have to edit my equation. So now it's 5.50X plus 49.95 and then I'm going to keep some of the X values because we do have a 310, but then I have to change this 100 to the 50. Then this 150 to 100. And honestly, we can just keep the 200, 250, 300 because we'll need that to finish the table. Okay, so when we have 3 shirts, right here, as you can see, the equation didn't change. It's still 8x plus 15. So what I'm going to do is I'm going to manually change that in here because that was our old equation. So we have 5.50 x plus 49.95. And you can see the numbers have changed, right? So for 3 shirts, we have that it will cost $66.45. So I'm going to write it down here in the table as well. For 10 shirts, we have that it will cost $104.95. For 50 shirts, we have that it'll cost $324.95. For 10 shirts, we have, for 100 shirts, we have that it'll cost $599.95. So I believe we had 150 next and then 200, or we just had 200, 250, and 300. So we'll use that. Okay, so for 200, it looks like it is 1,149.95. Then for 250, we have 1,424.95. And then lastly, we have 1,699.95. Okay, so that was that. And then the next part is saying you have explored the cost of ordering t-shirts from two companies, the US Shirts and Hot Shirts. Your boss has asked you to determine which company has the better price for t-shirts in different situations. So we have to consider the graphs. So we haven't graphed it yet. I will show you afterwards what the graphs look like with the two lines for US Shirts and Hot Shirts. Notice that the graphs intersect at about 14,127. The point of intersection indicates where the total cost for each company is the same. Therefore, when US Shirts sells 14 shirts, the total cost is $127. And when Hot Shirts sells 14 shirts, the total cost is $126.95, which is about the same as $127. So I'm going to go ahead and graph it on Desmo. So we have one of the graphs, right? We have our second graphs, which is for Hot Shirts. So the equation I have to type in for US Shirts. So that's going to be Y is equal to the 8X plus 15. Okay, so as you can see, we are going to look for the point of intersection. So I have to zoom out. And then I'm going to go ahead and click on this right here, which is our point of intersection. So as you can see here, it has our X value is 13.98 and then our Y value is 126.84. So 13.98 is going to round up to 14, right? Because X represented the number of shirts. So you can't have 13.98 shirts. You would just have 14 shirts. And yes, we can write prices as 126.84, $126.84, but just to make it easier to round up to the nearest whole number, that's about $127. Okay, next for this turn and talk. So we have this graph, or we have this system of equations, I should be more specific, and we have to answer the question, what are the differences between the lines graphed? So I can see that both of them are non-proportional because they both do not go through the origin. And so that means that if they're non-proportional, we know that the equation that we can write for them is y equals mx plus b, that slope-intercept form. So remember from our vocabulary that m represents a slope, b represents a y-intercept, right? So from here, we can see that they both have different y-intercepts. And if we really want to be specific, we can say that this first y-intercept is 0, 3, so it's a positive number. The second y-intercept is 0, -2, which is a negative number, right? So one of the differences between the lines graphed, one of the lines has a positive y-intercept. And again, that was at 0, 3, while the other has a negative y-intercept. Which is at 0, -2. Okay, so the next thing that we have is our slope, right? And so whenever lines go down from left to right, that means that our slope is negative. And then whenever our lines go up from left to right, that means our slope is positive. So to continue talking about the differences, we're going to say one of the lines has a negative slope, while the other has a positive. Okay, so then we have to answer at what point do the lines intersect or meet, right? So we are finding the solution because anytime we have a point of intersection, that is our solution between the system of equations, between the two lines that are graphed. Okay, so this point right here looks to be about 1, 1. So our x-coordinate is 1, our y-coordinate is 1. Okay, so for this next problem, this is an I do. We actually have the same graph. So if we look, it's the same graph. But this time they gave us equations, right? And we have to verify. So this is the part where we're actually going to prove, or we're going to double check, confirm that that was the solution. So here it says graph the following equations in slope-intercept form. We already have the graph of it. And now we're given the equations, right? We have y is equal to 3x minus 2. So that was our slope of -2, or our y-intercept of -2. and then our slope was positive 3, just like we noticed when we talked about the differences between the lines. Then for the second equation, we have a slope of negative 2 and a y-intercept of positive 3. So just like we mentioned that the slopes, one of them is positive, one of them is negative. The y-intercept, one of them is positive, one of them is negative. Okay, so we're going to start by writing in our solution into this first blank. So it says the lines intersect. So the lines meet at the point we have 1, 1. Therefore, it represents a solution to the system of equations. And then next, we have to answer the second part, which is saying we can also use substitution. So substitution means to replace, to verify. Remember, verify means to confirm that the ordered pair blank is a solution to the system of equations. So remember that the solution is still the same. It's still 1, 1. And so now we have our equations, right? We have the y is equal to 3x minus 2 and y is equal to negative 2x plus 3. So we're going to have to plug in the 1, 1 as our x and our y values. So similarly to when we were working backwards to find our y-intercepts and we had to plug in an x and a y value from a table, this time we're just plugging it in. We don't need to solve for the y-intercepts we're given it, right? The negative 2 and the positive 3. But we do need to verify, we need to double check that the equation makes sense so that we know that that is actually a solution, that it works for both equations. So we have our x value is going to be 1, our y value is also 1. So that means that we have 3x minus 2, so we have 3 times 1 minus 2. And it says is equal to y, and it says our y value, our coordinate, our point is 1. So now I have to do the math. 3 times 1 is 3, 3 minus 2 is 1. So that is correct. So we verified that the solution does work for the first equation. Then for the second equation, we have our x value is still 1, and then our y value is still 1. So now we're going to plug that in. Negative 2 times 1 is negative 2. We have negative 2 plus 3. Negative 2 plus 3 is positive 1. So then the second equation has been verified with that solution. So now I can put it one last time. The ordered pair 1, 1 makes each equation true. Therefore, it represents a solution to the system of equations. For this, we have two equations, and it says using a graphing calculator, what is the solution to the system of equations? Okay, so we're going to have to type in the equations. I'm going to go ahead and clear this one so we can type in the equations. So we have y is equal to, our first equation is 2x plus 5. And then our second equation is y is equal to 2x minus 2. So I'm going to go ahead and delete this. We have 2x minus 2. And then from here, I'm going to zoom out to try to find the point of intersection. So as you can see, when I zoom out, I don't see where the lines would meet, right? So that means that if there's no point of intersection, there's no solution. The second question is asking if there is no solution or if there's no intersection, why do the lines not intersect? Well, we can see that there are two lines that are going the same direction and they don't intersect because these are called parallel lines. So the lines don't intersect because they are parallel. And then lastly, it says, how could you change one of the equations so there's only one solution? So looking at the equations, over here we have a y-intercept of positive 5. Over here we have a y-intercept of negative 2. And so we can see that that doesn't really have an influence if I go down to the y-intercepts on the lines not meeting, right? What does have an influence on that is we can see that the slopes are the same. They're both 2, right? So I'm going to say that if the slopes are the same, then there's going to be no solution because the lines will always be parallel. It doesn't matter if the slope is 2. It doesn't matter if both slopes are 100, both slopes are 50. So question number 3 is asking, how could you change one of the equations so that there's only one solution? So we're looking for one solution. And so if the slopes are the same here, I'm thinking that if we change one of the slopes, there'll be a solution. So I would change the slope of one of the equations. And we'll go ahead and try that. So right now, both slopes are 2. So let's say one of the slopes is going to be 5. So I'm just going to change the slope of the first equation. And then if we look, we can see that, yes, now there is a point of intersection. It's at this negative 2.3333, negative 6.666. Okay, so we are going to skip over this you-do, and we're going to go ahead and work on this last problem together. So it says Steve started with $250 and spent $25 per week. And then it says Chelsea started with $30 and she saved $30 per week. It also says that we have to use X for time and Y for savings. So we're writing an equation with X and Y. And then, of course, the instructions are to write an equation to represent each situation. So we're going to start with Steve. So for Steve, it said he started with 250. So we have Y is equal to 250. Then it says he spent. So spent means that we're minusing or subtracting, right? And then it says $25 per week. So remember, per indicates that the 25 is the slope, because per means that we're either multiplying or dividing. In this case, we're multiplying. So our equation for Steve is Y is equal to 250 minus 25x. Then our equation for Chelsea. So Chelsea started off, Y is equal to 30. So she started off with $30. And then it says she saved. So because she's saving money, she's going to be adding money. So plus 30. It says $30 per week. So again, 30x. So yes, X represents the time, and specifically the time in weeks. And then Y represents the savings or the total amount. Okay, so we wrote the equations. Of course, now we're going to have to graph the equations. So I'm going to go ahead and, of course, change the equations in here. So the first equation we have is Y is equal to 250 minus 25x. Then our second equation is Y is equal to 30 plus 30x. And I'm going to try to find the point of intersection. So I have to go upwards, zoom out, then I zoom in. So it looks like that point right there, 4 comma 150 is our solution. So we have 4 comma 150. And then our X value is going to be the 4. Our Y value is going to be the 150. So then the question is asking, when did Steve and Chelsea have the same amount of money? And how much do they each have? So we remember that 4, or our X value, represents the time in weeks. And so after 4 weeks, remember that Y, or the 150, represents the total amount or the savings. So after 4 weeks, Steve and Chelsea both have $150. And then the rest of the worksheet is independent practice. Thank you so much for following along in today's lesson, and see you in the next one.